Okay, so we've got a nice problem to think about here where it's in 3D. We need to come up with the equation of three different skew lines so that the distance between each pair of lines is just 1 unit. They're all 1 unit apart from each other. And if you have a think about this, you might come up with an example kind of looks like this, where you've got three parallel lines. They form this sort of equilateral triangle. They're all 1 unit apart. So the distances are right here, but we're looking for skew lines. They all need to go in different directions, so sadly we can't have any parallel lines. So if you want to have a think about this for yourself, now is a good time to pause the video, otherwise I'll go into my solution. Okay, so for my solution, I start off by thinking about the coordinate axes, so your x-axis, y-axis and z-axis. So now this is a nice set of skew lines. And basically, because they all intersect, I was thinking, what if we move them apart a little bit, and then hopefully we can move them in such a way that the distance between each pair is going to be 1 unit. So we start off, what I've done here is I've written them out in this parametric vector form. So in red you've got the x-axis, so here lambda is a parameter as this varies amongst all the real numbers. This will give you all your different points on the x-axis, and the same for the green is the y-axis. Blue is your z-axis with mu and nu as your different parameters. So at the moment all of these lines intersect, which is no good. We need to move them apart so they're all 1 unit away from each other. So that's sort of minimum distance. So let's move the z-axis. All we're going to do with this is we'll move it 1 unit in the x direction, we'll move it 1 unit in the y direction. You can see here the equation's changed. Instead of x equals y equals 0, you've now got x equals y equals 1 for all of your points on this line. So now this line it's 1 unit away from the x-axis, it's 1 unit away from the y-axis, which is great, but our green and red lines, the x and y-axes, still intersect. So all I'm going to do next is I'm going to move the x-axis. We'll move this up 1 unit in the z direction. See the equation's changed there again. But now you can see this is 1 unit away from the green line, the y-axis. It's still 1 unit away from the blue line because it's moved parallel to this blue line. And you can see the blue and green, these are still 1 unit away as well. So there we go, we've got a nice sort of trio of lines. They're skew and they're all 1 unit apart. You can see here the little yellow lines, that's just indicating where the shortest distance between each line is, going in this direction that's perpendicular to both the lines. And if you want to really convince yourself of this, you can just have a look here. In 3D, these are indeed the shortest distances between these lines. And if you didn't like that sort of explanation, I can show you a different way of sort of coming up with this example. If you imagine you start off with just your unit cube here, and then let's take one of the edges at the back, and we'll include this as one of our lines. And then, because we know this is the unit cube, let's take one of the other edges, and we'll include that as one of our other lines. And these are definitely 1 unit apart. And then what we can do now is we can include, this will be the y-axis, we can include this as our third line. So they're all going in different directions. We've got our skew lines. And you can see there just from this unit cube. It's another nice way of seeing that these are all 1 unit apart. So they're shortest distance between each other. And there you can see it sort of in 3D to really help you visualize.